Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Bilal from University of Djellil. My objective for this paper is the effects of grain size and trap density on electrical conductivity in polycrystalline silicon. The polycrystalline silicon is an assembly of small crystals or grain separated from each other by a highly disordered area called the grain boundary. In the thin layer of polycrystalline, the electrical conductivity is sensitive to the average grain size and trap state density as the grain boundary. We are using the model of Seton to calculate the higher potential barrier and the effective mobility as the grain boundary. The result shown in the figure number 3, we have in first we have the grain size variable, and in second we have the density of state is a variable. In the figure number 4 and 5 we have the variation of mobility as the grain boundary, with first L is or the grain size constant. In second we have the density of state is a constant. The effect of grain size is independent of the effects of trap density on the potential barrier. The minimum mobility value depends on the doping, and the minimum occurs when the grain size multiplied by the density of doping equal the trap state density. The mobility increases proportional with the grain size. Conclusion. In this work, the electrical behavior of grain boundary was studied by the determination of the potential barrier and effective mobility, as well as the relation between the potential barrier and the grain size and the density of the trapping state in the grain boundary. The conductivity in the polycrystalline material is good not only when the grain are large or when density of the grain boundary is low, but when the grain and the grain boundary is of specific size and the density and predefined dimension established from experimental condition. Assalamu alaikum wa rahmatullahi wa barakatuh.